Welcome to Math Tutorials. In this video, we are solving every question of exercise 7.8 of Chapter 7, Integrals, from the NCERT Mathematics textbook for Class 12, Part 2. Exercise 7.8 evaluates definite integrals by the second fundamental theorem. 22 questions where the antiderivative is found and then squeezed between the limits, ending with 2 multiple choice. Here is the list, grouped. Question 1. Our first definite integral, the second fundamental theorem in its simplest setting. Antiderivative, then upper value minus lower value. The antiderivative of x plus 1 is half x squared plus x. Evaluate 3 halves minus 1 half 2. Question 2. The log between 2 and 3. One clean subtraction of logs. The antiderivative is log x. Combine into one log. Question 3. A polynomial across 1 to 2. Integrate term by term, then subtract. The antiderivative collects 4 terms. Upper minus lower, 64 thirds. Question 4. Sine of the double angle over the first eighth turn. Cosine at the end points. The antiderivative is minus half cosine 2x. Cosine of pi over 2 is 0. Cosine 0 is 1 half. Question 5. Cosine 2x over the quarter turn. Sine of pi vanishes. Half sine 2x at the end points. Both signs vanish. The integral is 0. Question 6. The exponential between 4 and 5. E is its own antiderivative. Evaluate e to the x at the end points. Factor if desired. Question 7. Tangent up to pi over 4. The log of cosine appears. The antiderivative is minus log cosine. Minus log of 1 over root 2 is half log 2. Question 8. Cosecant between pi over 6 and pi over 4. The log of cosecant minus cotangent. Evaluate the standard antiderivative at both ends. Combine into a ratio. Question 9. The inverse sine formula over 0 to 1. Endpoints 0 and 1 give 0 and pi over 2. Evaluate inverse sine. Pi over 2 minus 0. Question 10. The arctangent over the unit interval. A quarter turn. Evaluate inverse tangent. Pi over 4. Question 11. The symmetric log formula between 2 and 3. 2 log ratios subtract. The antiderivative is half the log of x minus 1 over x plus 1. The ratios combine to 3 halves. Question 12. Cosine squared over the quarter turn, the half angle identity. The sine term vanishes at both ends. Convert and integrate. Only the x term survives, pi over 4. Question 13. The half log of the quadratic. 10 over 5 is 2. Antiderivative half log x squared plus 1. Half log 2. Question 14. Split into the derivative part and the arctangent part. 1/5 log plus 3 over root 5 arctangent. The 2x part is 1/5 of the derivative of 5x squared plus 1. The 3 needs the scaled arctangent. Evaluate log 6 over 5 plus the arctangent of root 5. Question 15. U equals x squared inside a definite integral. Change the limits, along with the variable. With u as x squared, the limit stays 0 to 1. Half of e minus 1. Question 16. Improper, divide first, then partial fractions. 5 minus a proper fraction. Division and the split over x plus 1 and x plus 3. Integrate and evaluate between 1 and 2. Question 17. 3 easy antiderivatives, evaluated at pi over 4. Tangent, the quartic and the line. Antiderivative, 2 tangent plus x fourth over 4 plus 2x. Tangent of pi over 4 is 1. Question 18. The bracket is minus cosine x in disguise. Sine of 0 and sine of pi both vanish. The half-angle difference is minus cosine x. 0 at both ends. Question 19. Split into the derivative part and the arctangent part. 3 log plus 3 halves arctangent. 6x is 3 times the derivative of x squared plus 4. The 3 gives the scaled arctangent. Evaluate 3 log 2 plus 3 pi over 8. Question 20. By parts on the first piece, a scaled cosine on the second. The xe to the x part evaluates to exactly 1. Xe to the x integrates to x minus 1 times e to the x, giving 1 across 0 to 1. The sine gives the cosine bracket. Collect 1 plus 4 over pi minus 2 root 2 over pi. Question 21, multiple choice. Arctangent between 1 and root 3. Pi over 3 minus pi over 4. Inverse tangent of root 3 is pi over 3, of 1 is pi over 4. The difference is pi over 12. Option D. Question 22, the final one, multiple choice. A scaled arctangent, 1/6 arctangent of 3x over 2. The antiderivative is 1/6 arctangent of 3x over 2. At the upper limit, the argument is 1, giving pi over 24. Option C. That completes all 22 questions of exercise 7.8. In the next video, we will take up exercise 7.9 on evaluating definite integrals by substitution. Thank you for watching. If you found this video helpful, do like it, subscribe to math tutorials, and share it with your friends.